Hello guys, how are you doing today? I'm going to ask you for another extra credit if you want to do it. Of course, this is up to you. As part of the homework, I assigned you a problem that looks like this one here. Now I want you to do a little bit extra and go further, an extra step in this problem. This problem that I assigned in the homework only asks you for decomposing or resolving this force or finding the components of this force F2 according to the axis U and B. Now I want you to do the force F2, the force F1, calculate also the resultant force and express the components of that force along the axis UV. But I want you, there's a little twist here, to do it analytically and graphically. And the reason is because I want you to understand what is happening here. So I found this little thing on internet, and I'm gonna use this to show you, at least I'm gonna work only with the force F2, and I'm gonna show you how I will approach graphically the decomposition of the force F2 using the graphic method. So basically the first thing that you have to do is plot your axis, and I'm gonna plot my axis here. So this is the u-axis, is this one here, u, and it's pointing in that direction, is the positive direction. So I'm gonna use this line here as my u-axis because it's easier to do. It's right there. So this is gonna be my u-axis here, and remember the u-axis, the positive direction, is gonna come in this way. Now the v-axis here, which is this one, is making 70 degrees with my u-axis. So I can use my protractor, which I printed from the internet. You see, this is the 70 degrees here, 70 degrees here. So I'm gonna make 70 degrees. This is 70 degrees between both axes, and I'm gonna continue it to this part here. So 70 degrees, I should be in 250 because this is 180, 250. There you go, 70 degrees. This angle here is 70 degrees. That is what the problem is telling you. And this is going to be the positive direction for my v-axis. Now I have my two axes drawn here and defined. Now I have to draw my force 2, this force 2, the direction of the force 2. And the problem is telling me that that force 2 makes 45 degrees with the v-axis in this direction. Well, if I'm here at this point and I have to measure 45 degrees, I have to go 10, 20, 30, 40, and 45. 45 degrees here, right there. You can use also a protractor if you want to, you know, those plastic transparent ones. They looks like pretty much like this. So once again, you have 10, 20, 30, 40, 45 degrees. And if this is gonna be, I'm gonna make it with a different color. This is gonna be the direction of my force 2. Force 2. This is gonna be the direction for my force 2. And I know this angle here is 45 degrees. 45 degrees. Now, if you are going to solve this graphically, which is what I'm intended you to do, part of it at least, we have to come with some way of measurement for those units, to measure those units. 500 newtons. Well, you have to come with a scale. I'm gonna use centimeters because it's easier for me to work in this scale, so I'm gonna work centimeters, and I'm gonna set up on a scale. I'm gonna say, oh, if I want to represent 500 newtons, I'm gonna measure 5 centimeters in my scale. In other words, 1 centimeter is 100 newtons. That's gonna be the graphic scale that I'm gonna use. So I'm gonna come here, and I don't understand why this makes me make it backwards, but okay. I'm gonna put my 0 here, and I'm gonna measure 5 centimeters because 5 centimeters should be the equivalent of the 500 newtons that I'm looking for. 500 newtons is gonna end right there. 500 newtons. This is gonna be my force F2, pointing in this direction. You have to be really accurate when you do this, otherwise your results are gonna be a little bit off. So this is gonna be my force F2 here, F2. Now, the way you decompose this graphically, and not graphically also, but graphically, is that you have to come and find the components of this force parallel to those axes. And in order to be parallel to those axes, guess what? you have to draw a parallel line. So how do you draw a parallel line is pretty much up to you. You can use a square triangle like this, a square straight edge. You can put it here, and I know this, if I make a line at this point now, okay, you see I'm putting this here, and with the perpendicular edge here, this one, I'm putting another ruler, and if I keep this fixed now, I can come and make any amount of parallel lines here. But the parallel line that I'm interested has to coincide with the end of my force 2, right there, right there. And I'm gonna use, where's my green color? Nobody moves. Here, okay. So I'm gonna make this component, I'm gonna draw this component in this color. This is parallel to the u-axis, right there, parallel to the u-axis. Now I have to do the same thing and draw a line parallel to my v-axis. Remember what I told you? You put your straight edge or square triangle. I don't know why they call this a square, because it's a triangle. But so you put that thing over there. Once again, you put your let me go lower here, right there, coincide with the line. Okay, now you put the other ruler here, and now if you move this and you slide this, you can make lines parallel to my v-axis. And once again, I'm gonna make that line to coincide with the end of that point. That will be the end of that point. So I'm gonna draw a line here parallel to the other axis, to the v-axis. And if you realize, what we have done here is that we have created a parallelogram. You see that parallelogram there? Okay, basically those are gonna be the components of that force. How do we know the direction of the components for that force now? Well, remember, you have to go tip to tail. This is like doing addition, the same thing. So if I add the two components, I have to get the force. This is my force 2. So if I want to go from this point, which is the beginning, to that, this component has to point in this direction, and the other component has to point in that direction. What is this component? This component is going to be the u component. What is this component? This component is going to be my F2u. This is going to be my F2v. If I want to know the values for those components now, I'm going to measure graphically. This is the part that I'm telling you graphically. So if I want to know how much is V2, I'm going to get this point here, and if I measure this thing, this is 4.5, 6, 7, 8, 4.8ish. So my F2V, if it's 4.8 centimeters, that should be, for my force 2V component, that should be approximately 480 Newton. I do the same thing now with my force F2u, and if I measure the force F2u here from this point to this other point, I have 3.5678, so 3.8 centimeters. If I put these 3.8 centimeters back into my scale, F2u should be approximately 380 Newton. And I get these two values graphically. There is a reason I want you to do it graphically, because when you have this problem, usually you are so brainwashed, so focused. I always compare like the Pavlov experiment with the, the little bell and the dogs and the salivation when they were about to get fed. So every time that you see something like that, you say F cosine, F sine, And that's not true. That's only true when the axes are perpendicular. Now, if I want to show this result analytically, now I get the problem. Where is my problem again? I have such a mess here, but hey, that's my mess. It's my kind of mess. So, this one here. If I want to solve now this analytically, I make use of this. I can use it. I can do it here. So I can make use of the same page. I know this angle is 45 degrees, and I know this angle is 70 degrees here. So if this angle is 70 degrees for two parallel axes cut by a line, these alternate internal angles, this one here should be 70 degrees also, because this line and this line is parallel, and they are cut by a straight line. So if this is 70 degrees, this is going to be 70 degrees. Same situation applied to these two. This line and this line are parallel. If this is cut by a line, both parallels, this angle here should be 45 degrees. And if this angle here is 70 degrees and this angle here is 45 degrees, then the other angle that I'm looking for, the summation of the three angles of a triangle has to be 180. So the summation of this angle here should be then 115, 180 minus 115, that means 75 degrees. If my calculations are not wrong, which I think they are, because 180 minus 115, that's equal to 65 degrees. 65 degrees. So this angle here is 65 degrees. Is that correct? Yes, that's correct. 65 degrees. Okay, and this is 45 degrees. You can start and do all your things again, and you say, okay, if this is 65 degrees here, then this is also 65 degrees here, and then you say that this is 65, this is 45, this is 70, this has to be 70 degrees here. And now you can use any triangle that you want to use, but these are not right triangles, so you have to use the law of sines. What is the law of sines? The law of sines states that if you have a triangle like this, and you call this angle A and this side A, same with this angle B, and this side the opposite side B, and this angle C and the opposite side is C, then you can say that the sine of A divided by the opposite side has to be equal to the sine of B divided by the opposite side, and has to be equal to the sine of C divided by the opposite side. That's basically the law of sine. If I have to solve this problem by the law of sine, I know this value, and I'm not going to do it graphically now. Now this force F2 is 500 Newton, and this angle is 70. So I can say that sine of 70 degrees divided by the opposite, which is 500 newtons, has to be equal to the sine of 45, this angle now, divided by the opposite, but the opposite is F to U. This side is F to U. And has to be equal to what? To the other angle, which is this one, 65 degrees, divided by this other side, and this other side is F2B. Now you take a pick. Now if I do that, and I want to solve for F2U, I'm gonna change the paper, hold this here. Okay, and I'm going to apply this equation, F2U, I pass F2U to this side and the rest to this side. So F2U is going to be equal to sine 45 degrees divided by sine 70 degrees multiplied by 500. F2U, sine here, 500 there. So if I do my calculator, sine 45 degrees divided by sine 70 degrees multiplied by 500, we get 376.2 Newton. Now if I do the same thing with now F2V, which is the other one that I'm looking for, I say F2V is gonna be equal to, now I use this one, f2b sine 65 divided by sine 70 degrees multiplied by 500, and you get a value of f2v equal to sine 65 divided by sine 70 multiplied by 500, and you get a value of 482.2 Newton, and that's analytically. Now compare the values that we got before. We got graphically, of course we have errors in the measurement, that's normal, right? So 380, 376, and f2b 480 versus 482. I think that's pretty awesome. Those results are really good results. Now the only thing that we are missing here, and we have to be really careful, is what the question is asking you. If the question is asking you for the magnitude of the component, you could care less about the sign and the direction. But if the question asks you for the components only, you have to be really careful. Now look at the components. F2v, which is this component, is pointing toward the v direction. That means this is positive. But my u direction is here, and the component f2u is pointing to the left. The right is a positive in this case, so the left should be negative. So whatever you have that component f2u, you should have a negative sign in front of it, unless the problem is asking you only for magnitude. You don't have any sign. You just care about the 400 newtons, the 300 newtons, or whatever amount of newtons, and not the direction. Now what I want you to do is check this out, replicate what I did, do the same thing now for F1. Calculate the components of F1 also. Calculate the resultant force. Calculate the components of the resultant force. And as an extra thing, I want you to also work this problem out. And this one, actually, you just solve it. If you want to do it with the protractor, awesome. I would really love you to do that. But if you don't want to do that, at least solve this problem and show me the results. This is an extra problem. This is not in your homework. So solve this problem. I'm just gonna put it there for some seconds, and you take a picture. You know, you are savvy electronically. You can do whatever you want to do with that. But this is a really this is a cool problem, because this is like a truss, and we're gonna be covering trusses in chapter 6. But the important thing is that the problem is asking you to find the components of this force over those two axes, or those two bars, or those two members. And by the way, this is the same method that we're going to be using for calculating the trusses. It's called the method of the joints. But I want you to do it, and I want you to calculate those two forces over there. Regarding the sign, well, yeah, imagine that everything that goes in the direction of the element like that is positive and is coming. Don't worry about the sign. Just calculate the magnitude for that, because we're going to cover trusses later on, and I don't want to start confusing you. But I would like you to calculate the components of this force with respect to those two axes, if you want to say that. Another thing that I wanted to tell you before I finish this video, because it's going to become too long and then you fast forward it and you miss information, is just a quick explanation of why when you have a right triangle and this is 90 degrees, we are also using the law of sines. The only difference is that we call this, for example, this side A, this side B, and this side C. And if you want to calculate how much is the side, let's say this angle is 30 degrees and this angle is 60 degrees to make it easier. So if you want to calculate this side B, you say B is equal to what? B is equal to C multiplied by sine of 30. Right? B is equal to C multiplied by sine of 30, because it's the opposite. If you want to calculate this side, you can do the same thing, right? You can say that A is equal to C multiplied by sine 60. But you are doing the law of sines here. It's the same thing. If I do the law of sines, then what is the law of sines? C over sine of 90 has to be equal to A over sine of 60, and it has to be equal to B over sine of 30. What is the sine of 90? 1. So this part is 1. So basically, what do you have? If you want to calculate A is equal, pass this to the other side, C sine 60. And if you want to calculate B, pass this to the other side, is equal to C sine 30 degrees. So yes, every time that you use sine and cosine in a right triangle, what you are doing in reality is the law of sines. It's just that it's a simplification because the sine of 90 is 1. So I don't want to take more of your time, although I know that you love watching me. Who wouldn't, by the way? So you go over there and solve this problem. Once again, 3 components, graphically, analytically, and I don't know, it would be nice if you also work this out and include it as part of your extra credit assignment. When I say it would be nice, what I mean in reality is do it. Okay? So see you next time. I'm gonna post this right now, and be safe because you know what is happening now, what is coming, the hurricane. And see you later. Bye.